What if the sea still hides giants bigger than the megalodon? For centuries, our oceans have been a canvas for our greatest fears and wildest imaginations. We've filled the abyssal plains with krakens and sea serpents, creatures born from the anxiety of the unknown. But in the modern age, one name dominates the conversation of prehistoric sea monsters: Outsizes Megalodon. This colossal shark, reaching lengths of up to 60 feet, has been extinct for over 3 million years. Its fossilized teeth, the size of a human hand, are the only tangible proof of its reign. Yet, the myth persists. Tabloid headlines and blockbuster films fuel a fantasy that this apex predator somehow survived, lurking in the crushing pressures of the deep. But what if the truth is even more astonishing? What if the question isn't about a ghost from the past, but a giant we've never met? Scientists just found clues that something far larger may roam the deep. This isn't about resurrecting a fossil. This is about discovering a new reality. The evidence isn't found in sensationalized footage, but in cold, hard data. It's a story told not through myth, but through the rigorous language of science. And the first chapter of this story is written in sound, not myth, bioacoustics. Deep beneath the waves, in a world devoid of light, sound is the primary sense. Whales communicate across entire ocean basins, their songs a complex tapestry of social connection. For decades, marine biologists have used hydrophones, sensitive underwater microphones, to eavesdrop on this world. They've cataloged the clicks of dolphins, the moans of humpbacks, and the powerful, low-frequency pulses of blue whales, the loudest calls in the animal kingdom. But recently, these hydrophones have started picking up something else, something that doesn't fit. These are ultra-low-frequency vocalizations, signals that fall below the known range of any documented marine species. On a spectrogram, they appear as colossal signatures, dwarfing even the calls of a fin whale. The physics of sound and water are unforgiving. To produce a call this low and this powerful, the source must be immense. The resonant frequency of an animal's vocalizations is directly tied to the size of its sound-producing organs, and by extension, its body. Initial models, while highly speculative, suggest a creature of a scale that defies our current understanding of marine biology, an animal potentially far exceeding the size of a blue whale. These aren't random noises. They exhibit patterns, suggesting they are biological in origin. A call, an answer, a presence felt but not seen. The acoustic evidence is compelling, but it's not the only clue. For years, researchers have photographed whales bearing inexplicable wounds, giant bite marks. These aren't the neat circular scars left by cookie-cutter sharks, or the parallel rakes from the teeth of an orca. These are massive arcing wounds and puncture patterns that don't match any known predator. Some scars suggest a bite radius far wider than that of a great white, or even a sperm whale, the only creature known to prey on giant squid in the abyss. When scientists attempt to model the jaws that could create such marks, the results are staggering. The sheer force required to puncture the thick blubber and muscle of a great whale is immense. The tooth spacing, inferred from the wound patterns, suggests a predator of unprecedented size. Of course, there is uncertainty. Scars can stretch as a whale grows, and collisions with ship propellers or undersea equipment can cause unusual injuries. But some of these marks are so distinct, so seemingly biological in their pattern, that they remain a profound and unsettling mystery. Physical evidence of a violent encounter in the deep. Unexplained sonar blips are changing the game. Beyond passive listening, science actively probes the depths with sonar. And here too, anomalies are surfacing. Military submarines and advanced oceanographic vessels have occasionally registered biologicals, sonar contacts that aren't submarines, seamounts, or schools of fish, of a truly gigantic scale. These are not the fleeting phantom echoes that can be caused by thermal layers or signal interference. These are solid, trackable returns, sometimes referred to as unidentified submerged biological phenomena or USBPs. The data suggests objects moving with purpose at depths far below where most large whales venture. The estimated target strength, the acoustic size of the object, sometimes exceeds any known living creature. But sonar has its limits. It can be deceived by dense shoals of squid or unique geological formations. A single massive return could be a tightly packed group of smaller animals. Without visual confirmation, a sonar blip remains just that, a ghost in the machine. Yet, when these blips coincide with the locations of the strange acoustic signals and reports of scarred whales, a pattern begins to emerge, demanding further investigation. This hunt for a modern leviathan isn't new. 19th century whaling logs are filled with accounts of sundry great monsters and encounters with creatures that defy easy classification. While many can be dismissed as exaggeration or misidentification, some are strikingly consistent. Today, the search is far more systematic. Expeditions like the NOAA's Okeanos Explorer and private ventures from institutes like Schmidt Ocean are mapping the deep sea in unprecedented detail. They aren't explicitly looking for monsters, but their advanced sensor suites are the most likely tools to find one. Datasets from these missions, acoustic recordings, sonar logs, environmental DNA samples, are now being cross-referenced by dedicated teams, searching for the needle of a giant in a planetary haystack. The technology driving this search is extraordinary. Global hydrophone arrays, once used to track submarines during the Cold War, now listen for the pulse of the planet's hidden life. Autonomous underwater vehicles, or AUVs, glide silently through the abyss for weeks at a time, collecting data far from any surface ship. When an anomaly is detected, remotely operated vehicles, or ROVs, can be deployed. These tethered robots are our eyes and hands in the deep, capable of withstanding immense pressure and beaming back high-definition video from a world of total darkness. The sheer volume of data is a challenge in itself, requiring sophisticated AI algorithms to sift through terabytes of information, flagging potential signals for human analysis. Could these be ancient survivors or new evolutionary heavyweights? Before we declare a new species of megafauna, we must face the powerful counter-arguments from the scientific community. Skepticism is the bedrock of good science. The first major hurdle is energetics. A warm-blooded creature the size of a skyscraper would require a colossal amount of food. Where is this food source? The deep ocean is largely a food desert. While a blue whale filter feeds on dense swarms of krill in productive surface waters, a predator of that size in the abyss would need to find and consume other giant animals with a frequency that seems ecologically unsustainable. Then there's the fossil record. While incomplete, it gives us a good history of life's largest players. We have fossils for Megalodon, for the giant ichthyosaurs of the Triassic, and for the ancestors of modern whales. A creature of this proposed scale existing for millions of years should have left some trace, a bone, a tooth, something. Its absence is deafening. This leads to a critical question. If it exists, is it a relic from a bygone era, a living fossil that somehow escaped extinction? Or is it a more recent evolutionary development, a new branch on the tree of life that grew to immense size in the unique environment of the deep sea? Either way, the ocean just got a bigger mystery. The implications of such a discovery would be monumental. It would fundamentally rewrite our understanding of marine biology, ecology, and the limits of life itself. It would also raise immediate and complex ethical questions. How do we study such a creature without harming it? How do we protect a species whose habitat is the entire global ocean, an environment already under threat from climate change, pollution, and noise? The discovery would not be an endpoint, but the beginning of a massive new undertaking in conservation and science. It would ignite public fascination, inspiring a new generation of explorers, but also potentially attracting unwanted attention. And so the search continues, fueled by tantalizing fragments of data. The strange sounds from the abyss, the cryptic scars on the world's largest animals, and the ghostly blips on sonar screens. Each piece of evidence, on its own, can be reasonably questioned. But taken together, they paint a provocative picture of a mystery that science can no longer ignore. The line between myth and reality has blurred, not by fantasy, but by the steady accumulation of scientific anomalies. The teams working on this problem are not monster hunters. They are methodical researchers pushing the boundaries of ocean exploration. They are connecting the dots between different fields, acoustics, biology, engineering, in a race to solve the puzzle. Every new piece of data, every refined algorithm, brings them a step closer to an answer. The question is no longer, we will find something new in the deep, but it will be, and how it will change our perception of the planet we thought we knew. Science is sprinting to catch up to the whispers coming from the dark. The ocean guards its secrets well, but with each passing day, our ability to listen, to see, and to understand its deepest corners grows stronger. The age of discovery is not over. It has simply moved into the abyss. Subscribe if you want more myth versus science deep dives.